Hi students, now we will discuss concept of magnification in case of spherical mirrors. Firstly, I will discuss lateral magnification or transverse magnification. Another name is transverse, lateral or transverse magnification. Actually, magnification can be defined as size of image unto the size of object. In case of lateral magnification, size means height of the object or size of the image. If you observe, for lateral magnification, magnification m is equal to height of image by height of the object. This is lateral magnification definition. To understand lateral magnification, I take a concave mirror, pole, focus, center of curvature. Suppose, imagine any object is kept beyond the center of curvature. If I draw ray diagram, if a ray moving parallel to the principal axis, reflection takes place through focus. Minimum 2 rays are required to locate image. If a ray moving through focus after reflection, it will move parallel to the principal axis. I got this edge here. We can observe that image is formed here. This is image. Avoid the confusion, I delete these rays. Please observe. These rays are not required. Just we have to know, we have to realize that image is formed here. Object position, image position. Now, if you remember the rule, if any light ray incident at pole, it will take reflection symmetrically opposite angle. This way, reflection takes place. Even I use this rule, and through the center of curvature, image finally formed here only. Understand? Now you can observe here two triangles. This is one big triangle and this is another small triangle. Second one is small triangle, big triangle, small triangle. Can I say this is u, object distance, all distances are measured from the pole, u, and this become image distance, v is the image distance. If you observe first triangle, light follows laws of reflection, angle of incident, angle of reflection has to be same. Let theta, angle I equal to r is equal to theta, I go with theta. From the big triangle, can I write tan theta is opposite by adjacent. Opposite is height of the object, adjacent is object distance. So HO by U. And similarly, if I write tan theta for the image, theta remains same. For the image, you can write height of the image. This is h suffix I, height of the image, and to the image distance v. So finally, we can equate these two. HO by U is equal to HI by V. If I equate these two, what we will get? HI by HO is equal to V by U. So further, what is HI by HO? The ratio of height of image unto the height of the object, magnification. So instead of this, we can write magnification M. Now if I apply sign convention, below the principal axis heights taken as negative, this become height negative. Above the principal axis positive, plus V negative, object distance negative, velocity, image distance V negative, object distance U negative, negative. These both are finally cancelled. So final lateral magnification formula is M is equal to height of image unto the height of object, that equal to minus V by U. This is the final formula. Simply you can write M transverse is equal to minus V by U. Lateral magnification or transverse magnification formula. Next, we will discuss longitudinal magnification. The next type is longitudinal magnification. Here, magnification defined as length of image unto the length of object. Length of image by length of the object. Actually, size of image unto the size of object. Here, size means length along the principal axis. Suppose if I take a concave mirror, you have to consider here any object along the principal axis. Here, height is negligible. Suppose I kept any object here along the principal axis. As a result, we will get image inverted manner between C and F. Object, this is image. I indicates that image. Length of the image onto the length of the object. If you observe, if the size of the object is large, then you have to use the magnification formula as V2 minus V1 by U2 minus U1. So minus will come, sign convention. Actually, magnification M is equal to minus V by U. Along the principal axis, linear magnification is nothing but longitudinal magnification. So same you have to consider this formula only. Why? Because along the principal axis, length along the principal axis. So for object is large, you have to use this formula. For small objects, the size of object is very small, then magnification M become change in image distance by change in object distance. We have to use this formula dV by du. Further, dV by du, this is nothing but replica of differentiation. You have to differentiate the mirror equation here. If you observe, u is the object distance, v is the image distance. Suppose if I move the object towards the mirror, image distance also moved. So here u and v remains not constant. If you are moving this, this become also moved. But if you observe, focal length of the mirror remains constant. Mirror focal length fixed here. Apply mirror formula 1 by f is equal to 1 by v plus 1 by u. 1 by v plus 1 by u. We can also written as f inverse is equal to v inverse plus u inverse. By differentiating this equation, with respect to time, differentiation of constant is 0. d by dt of f inverse is equal to d by dt of v inverse plus u inverse. Differentiation of constant becomes 0. This becomes 0. So 0 is equal to, if I differentiate this term, minus 1 by v square dv by dt will come. Why? Because we know the formula d by dx of x power n means n into x power n minus 1, differentiation formula. The standard formula we will use here. But with respect to time, v and u are variables, so that you have to do internal derivative. So we will get dv by dt along with this term. And similarly for this term, for this u inverse, minus 1 by u square du by dt will come. Du by dt. Can I write this equation as, if I send this term this side, 1 by v square dv by dt is equal to minus 1 by u square du by dt. Dt both sides get cancelled. It can be written as dv by du is equal to v square by u square. What about dv? Dv is nothing but, for small object, dv is image distance, du is object distance. This can be written as, further this is nothing but magnification, it will come, minus is there, minus dv by du, it can be written as dv is equal to minus v by u the whole square, you can write v by u the whole square into du, where dv is position of image, position of image is equal to v by u, further magnification, m is equal to minus v by u, nothing but transverse term, minus m square, you can write square is there, m square position of object. So this is the final formula. Position of image is equal to m square times position of object. Finally, you can use this formula, dv position of image is equal to minus of v by u the whole square position of object. Next we will discuss aerial magnification. Aerial or superficial magnification we will discuss in two cases. Case 1, there is a concave mirror, any object, two-dimensional object is 2D, any two-dimensional object is kept perpendicular to the principal axis. As it is a principal axis, this is kept perpendicular to the principal axis. If you observe, this is the height of the image, object is kept here, this is object is between focus and center of curvature, image formed here, object, image, length of the object, and this has to be length of the object, length of the image, and this is also length of the image. We are discussing area, length under length, or length into breadth become area, that format. This is perpendicular to principal axis, this is also perpendicular to principal axis. Why? Because if you observe like this, principal axis perpendicular, this line perpendicular, and this line also perpendicular, perpendicular, means we can observe here the magnification is nothing but transverse magnification. So for this side, length of the image or height of the image, you can write height of the image is equal to m times height of the object. Why? Because magnification formula, magnification m is equal to height of the image by height of the object in case of transverse magnification. And similarly for this side, again height of the image m times height of the object, height of the image, or length of the image, whatever it is you can write. So hi into hi is equal to m into m square times ho into ho. Can I say length into breadth, area? So here area of image is equal to m square times area of object. This is the formula. Aerial magnification whenever the 2D object is kept perpendicular to the principal axis. Now if you observe case 2, imagine concave mirror, pole, focus, center of curvature. Let us say 2D object, nothing but a rectangle, a rectangular shape object is kept along the principal axis like this. Suppose this is object, this is image. A rectangular shape object is kept along the principal axis. Length of the object perpendicular to the principal axis, length of the image perpendicular to the principal axis. It resembles, if you remember, transverse magnification. What is the formula? Magnification transverse is equal to height of the image onto the height of the object. What is height of the image? Height of the image is Li. So we can write Li is equal to m times Lo, equation number 1. Now if you observe the width, this line, this is parallel to the principal axis. It resembles longitudinal magnification. So width of the image becomes m square times width of the object, equation number 2. If you remember, position of image is equal to m square times position of object, or length of the image is equal to m square times length of the object. This is longitudinal magnification. So Wi along the principal axis or Wo along the principal axis, that is the case. From 1 and 2, if I multiply Li into Wi is equal to m into m square m cube Lo into Wo, length into breadth, this height into this length is nothing but area. Area of image is equal to m cube times area of object. This is the final formula. Aerial or superficial magnification, two cases. Case 1, when 2D object is kept perpendicular to the principal axis. Case 2, when 2D object, nothing but rectangular shape object, is kept along the principal axis. Last type we will discuss volume magnification. Volume magnification. Volume magnification, here you have to consider 3D shape object, that is nothing but cube. Object is kept between C and F. Suppose I got image here like this. Here if you observe, length of the object in the direction of principal axis, that is along the principal axis. Length of the image along the principal axis, nothing but length of the image is equal to m square times length of the object. Why? Because it is resembles longitudinal magnification. Along the principal axis, object is lies along the principal axis. Length of the image m square times length of the object, longitudinal magnification. If you observe, this is area of object, area of image. Further we already discussed aerial magnification. Area of image is equal to also m square times area of the object, equation number 2. Can I write volume V is equal to area into length? Yes, we can write area of image, length of the image. So what is volume? Finally we will get volume of image. So volume of image is equal to area of image into length of the image. What is area of image? M square times area of object into length of the image, m square times length of the object. M square into m square, m power 4, area of object into length of the object, nothing but volume of the object. So volume of the image is equal to m square times volume of the object. This is the formula for volume magnification.